Hello, let's talk a bit about selection in OpenGL, how to select objects on the screen. So here we go, we got the example I ripped off from my Minecraft thingy video. So if we, let's start like this. This is the viewport. That's what objects are clipped against when you draw them. So if you draw an object outside of this, it will be clipped away. So you won't see it, it won't render, graphic card will discard it. So selection then. What happens if or let's say I want to select this one. I want to select that block in the back there. What happens if I change this viewport to be tiny viewport? Only that part will be viewport. So should the graphic card discard everything outside it and just render what's within it? Yeah, it should. So can we use that for selection? Yeah, in a way we can. So if you have your mouse pointer, let's draw a mouse pointer now. Really nice mouse pointer. No, let's draw it someplace else, by the way. Let's draw a mouse pointer over here instead. So we have our mouse pointer, and then we click with the mouse pointer, and we click at an XY coordinate on the screen, and that we know we can get XY coordinate quite easy where we are clicking. And then we're saying like, yeah, let's set that viewport to be here as a tiny little viewport. And then we render the screen. And what's not getting clipped away is what's within that small viewport there. If we could detect what was rendered there, we know where we clicked. And we can do that. So then we can select, in this case, this block then. We can select that block. So let's try the example and then go into the code, because I already coded it. I didn't record it, didn't think about it. So oops, now I clicked it by mistake. I was just going to spin it. Anyhow, so I click and I can select things. And I made it so I can, when I click, it rotates around the cube that should be at that location. So I can build, I can make some grass here. Let's rotate it around. And some water. And then I made it so if I click with the other mouse key, I can detect that. And instead of switching over the texture for this specific cube, I add the cube. But I add the cube above where I clicked. So let's click in the far corner over there. There we go. So added the cube. Let's add a few more. Rotate it around. And change the texture to something I like. So should we have a waterfall here? Oh, need to edit those. There we go. So now I can create my own Minecraft worlds, I guess. Now I can render it and select cubes, delete cubes. So if I select one, I change the texture, and again, and the last time I delete the block. So that's how this example works. And that's what I would step through this example to show how selection works, but it's a bit remove those. It was a little bit too hard to go through. I mean, it's a lot of code. It's not maybe not even the nicest code. It will be in the description if you want to look at this and download it and compile it yourself. It's not optimized in any way, so you can't build a Minecraft world from it, but maybe in the future. Anyhow, I was thinking about how we should walk through the code, and in the morning I thought, need something simpler than this, because I did this yesterday. I was like, maybe I could do a keyboard. So let's look at that. Piano. Let's fill in that. And when I remove the comments, for some reason it removes even those that should be there. There we go. So I made a klaviatur on Swedish, whatever that is in English. It's a scale, normal keys from the keyboard, and you can click them. And after I rendered this and made the codes like, yeah, that could work. Of course I didn't record it either, but anyhow, that could work. We can go through that code. But when I kind of went that far, I was like, it would be nice if the piano actually played something when I clicked the key, so I added in so it plays, and you can play with a keyboard also. Well, if you could, because I'm pressing the wrong keys. So I got this as an example, and it's also down in the description, and you can download it, and this puts together a kind of OpenGL rendering, OpenGL select, audio. It has translation and rotation in it, so if you want to rotate the keys around, but I skipped to adding the back of the keys, so they will be looking odd. There's no back face to them. And I think the shadows might be wrong. Anyhow, so I added in sound, but also the same thing there. It's like, this is a little bit much code to just show the selection part. So I made a third version, and that version is actually not that advanced. Not as the other two, is just the scaled down version of the piano. So here we go without the sound. So if we want to click that key there, let's go through this, how it works once more. Want to click there, we do click there. When we click there, we calculate the new viewport, that's tiny, and we re-render the screen. So nothing of this gets rendered, just render that little part, that little viewport there, and we figure out what was rendered in that one. Let's go to the code. So we have the draw piano key, which we can totally skip over. This draws the white and black keys. We have the render method that this time takes an GL enum, a mode, that's GL render or GL select. And select makes the selection, render is obvious, that renders the image. And I need to check if I'm in the mode select, because we're going to render the image first, we're going to set a new small viewport, and we're going to render it again with the selection enabled. And this time, when we have mode select, we will execute GL load name, and this will set the name for those objects that are rendered within the new viewport. So if we have the big viewport, and we have where we clicked, small one, So if we render a cube, let's say, outside that, it will be outside of the smaller viewport and the name will be discarded. But if we render a cube, let's get the yellow cube. But if we render a cube that hits this small new viewport, then we need to store the name. So the name we specify here will be stored somewhere when that happens. So basically it just checks like the polygon I want to render, is it clipped away or not? If it's not clipped away, let's store this value from that we have here from the load name. The load name and its name, the name is just an integer. But I had the integers from the keys here, so I made them ASCII values. But the name, this is actually a stack. So you have a name stack. Where should we draw the name stack? Here we go. So we have a name stack, and that gets filled in with this value in case we do not get clipped away. And in this case, say that this box represents the white key C. So then it's going to write down a few values in this name stack. It's going to write down we had one hit object. It's going to write down the near plane and far plane. I will tell you why later. So we have Z1, Z2, and after that it's going to write down the identifier, I believe. I'm thinking if it's number of identifiers now actually, but it's going to write down the identifier. No, it's just one identifier. So it's going to write down C in here. Object C, we had a hit on it. We needed to render it in this small new viewport, and let's add it into the name stack. So you can have multiple of these kind of records. So have this part. That can be, you have multiple of them. Now, I said that we had the C1 value and C2 value. That's a near and far value. So what happens if it tries to render multiple things into the same viewport, this tiny viewport? So in this case, why I actually draw a cube and just not a plane is because we have two planes that hit this viewport. We have this front-facing one. When that one was drawn outside the viewport here, gets discarded. But inside the viewport, it's drawn. But we also have the back-facing one in the back here. Maybe I draw that one. Hard to see. Let's draw it in another color. I draw this one in the background there. Back of the cube. Now I'm not drawing that with the keyboard. I'm just drawing if you turn the keys around, you will see that those polygons are missing. But that would also hit this window. But it has the same name. It has the same name set. But what it's going to do is it's going to say, hey, the Z value of the plane that was nearest to the viewer, meaning me, that will be put in, the Z value will be put in Z1, which we could call, can I draw an arrow? How hard should that be? That one, we could call it Z near. And then we have Z far, which is the one that's furthest away from us. And I was seriously confused why this is needed. But think about it like this. If you have even one more cube, can I get the red one? So we draw even bigger cube here. We draw an even bigger cube that's behind the yellow cube here. Really nice cube, by the way. Doesn't really look like a cube. So the red cube in the background, the yellow cube, and then our tiny viewport here for the mouse pointer. Now we actually have two objects, because the first cube here is that one I called C, and let's say the other one is represent the E key on the keyboard. So we got on the piano, so we got the C and the E, and both of those hit this small selection viewport. And we need to be able to select both of them. I mean, normally you say like, I just want to select the objects nearest to me, and that's like 90% of the time. But actually, when I thought about it, if you use Blender and you have a 3D view and you want to select a few vertices, it selects the vertex that's closest to you and the one behind it if that's underneath your mouse pointer. And yeah, I can get that in 3D model programs. I can get that where you want to select not just the object closest to you, but all of them in a straight line where you're clicking. I can understand that. So that's probably why it can write multiple of these records in this name stack. That was a lot of talking about name stacks. So if we are in render, if we are in selection mode, then it sets this name, and then it's just rendered as normal. And if you are in render, then it just skips setting the name, because I think it's a bit of overhead, because it's a pointer that I specify from program's memory. So I wonder if it's a bit overhead to fill in this one. And then I draw white keys, I draw the black keys, do the same, load the names of course. And the names of the different keys are up there. Then we have the display function, and that's exactly the same as normal. Nothing odd here. But what is odd that we have now, let's see if we can find it, the mouse function. Let's actually just show there. We provide a mouse function. We need to figure out the X and Y coordinate where I clicked in the window. And we get the X and Y. And we also get the state on the button we click with, so I can click with left or right button. And state is if the button is clicked down or up. So if it's not clicked down, then we just skip over this. And then we need to figure out what viewport we already have. So we have a window. There's our window, but someone might have resized it. Just made it a bit bigger. So we need to ask, hey, can I get an integer? I want the viewport integer, I want the viewport. And the viewport happens to be 4 integers, and that's the X, Y, width, and height. That's stored in there. Not actually sure what X, Y is used for. I guess it's 0, 0 to be honest. Oh yeah, now I know. It's if you have a big window and then you define multiple viewports. So say you only rendering in this part of the screen. I have another video when I actually did that. I think no, there was a video before that, right? It was a viewport window. So you can have like a 3D program with different 4 viewports in it. So you get the X, Y of the viewport, you get the width and height of the viewport. And then you tell OpenGL, hey, I want to have a selection buffer, and the selection buffer is this named stack I have been talking about. And you just need to define that to set the size of it. I guess if you have very many objects, maybe you could hit the size. I think it just skips filling it in when the size is full. I hope so, else you get the buffer overrun and everything crashes. And then they have something that I haven't seen before. OpenGL, I think it breaks the API. It doesn't work like other methods works. I mean, OpenGL is a state machine, and you modify the state of it, and you need to kind of remember yourself what state it was in. You can ask a few things. Like here, you asked for the viewport, and you got the viewport information back from OpenGL. But OpenGL, when you call it, normally does not return anything to you. But this method do. GL render mode, select, so we're going into select mode. And this one returns a value, which is really odd, because I think it would be stalling the render pipeline when we need to return something. So It's really odd. And you can type void just to tell other programmers like, I know that this method returns a value and I know that I am ignoring it. So now you know that I know and I wanted to ignore it. So don't come and talk to me about it. That's why you write void. You could just remove it. Actually, it looks nicer without it. But anyhow. So that's the name stack. It initializes the name stack. We're going to use names, and it requires that you push a empty name to start with for some reason. Apparently, it does not want to select the first ID you push down, first name. This in the book of Red, it's like you need to push down 0 first. Like, why? Seems like a bug to me. So that's why I say this part of the API seems a bit not finished. And then we switch to projection mode. We pushes the matrix. Apparently, I don't think that's needed because I load the identity after. Do I pop it? I do pop it. Okay. So you have a matrix stack. We haven't talked about that, but you can. Let's talk about it because we have it here. So if you have a matrix, that's projection matrix or model view matrix, you can push them down in the stack. So you get a, let's actually draw a stack of, let's call them matrices. So you can push them down. So this one was your projection, and now you get the new one. There's a copy of the other one, and we just loaded the identity matrix into that. And you can pop it up later. So we do that there. Then we have create a 1.1 pixel picking region near cursor key. And that's the GLU pick matrix. That's we're setting this new viewport. I'm not totally sure it actually is a smaller rendering viewport, but it behaves that way. And we need to send in the X and Y, and that's for the mouse coordinates. And here also one thing, like, did they really think through all of the API here? Because you need to invert the Y coordinate. And that's probably because you're counting from below in the window on OpenGL, but the mouse function here, probably you get the normal X and Y. Anyhow, so it sends in X, then it knows that the viewport width, no height, we have in position 3, so the last value in this viewport integer array. We need to convert that. And then here is the size of the new viewport, because I can make it bigger. I can have the full window, and I have my cursor. Yeah, I know I don't need to redraw everything all the time, but repetition is good, right? So that's my small viewport, but I could also say like, no, I want to select all of this. I mean, maybe it depends on your program or what you're doing. So you can make a bigger selection window. But I set it small, I set it to just 1 pixel. And then we go into matrix model view and set whatever we want there. By the way, this part should be the same as in the render function. So let's find the render function. Display function. Here, projection, load identity, model view, load identity. And then we render. Then we render everything, but we render it with select enabled. And when we change render mode back to render, normal render, because when we need to reset our state again, since OpenGL remembers, we does not. So if you don't do that, it won't render anything in the render method later. But when we're setting back the render mode, we get number of hits back. And that's how many of those entries that was written down to the name stack. Then we process those hits, we send in the buffer of the name stack and the mouse button for some reason. I don't think it's used. It's not used. I don't need it in this method. Anyhow, I used it before. I used it, I think, in the Minecraft level, because I need to know which button I press which one the hit is for. So we have the number of hits, name buffer or stack. We take the address of that one, and then for the number of hits, which hopefully is just one, we take the first entry in that array. That's the names, because we can have multiple names. We can hit multiple things. Multiple things could have been rendered in that small area. You can also have a hierarchy of IDs. So you can have you can render something with ID at 1, and then you render something within that as ID 2, and then you in this name stack you can get both 1 and 2 written down, even if the selection was just for the 2 here. Those could also, of course, probably be 2 different objects, but they can represent the same. So it could be represented like in the book it says a wheel and a wheel nut. I don't know. I haven't tried it. I don't know the format of it. So I'm a little bit out of my knowledge here about how this things work, right? So anyhow, we need to figure out which, or I need, you don't need, but I needed to figure out which object was closest to me. So I wanted to select the one nearest to me, and I think that's probably what you want to do also. So how I do that I set the depth and I set it to the max float value I can have, so it's farthest away it can be. And if we have a near value that's closer to us than the furthest away object we have can have, then we set the current depth to that value and say, hey, let's get the, I think it's 4th value in this buffer. That's 1, 2, 3, 4, yeah. So it's number 4th value in there, and that's the ID or name ID. And that's our selected key on the piano. So that's how we process it, and why you need to divide it by this to filter out the first negative bit. I have no clue. I don't think it's actually needed, but it was in the example, and I was like, yeah, we will use that example, so it works. Yeah, I don't like this part of the API, I must say. So that's how you process the hits. And I select the key, and the key, let's see where it's used. It's used in render later. So when I draw a piano key, I check if selected key equals white keys. So when I draw out the keys, of course, I just loop through all of the keys. And for each key, I have the musical note here. And that's my ID. So if that happens to be the same as the key I'm rendering right now, then we setting that it's pressed. And if it's pressed, then we make sure to modify the color a bit so we can see it easier. And just to be fancy, then we also translate it to translate the key down, so it's pressed down, and we're actually rotating a little bit also. I went and checked on my keyboard, and that's exactly how it is. So it should mimic that. Let's run it. And that works fine. And let's go back to the real piano and end the video with a real piano. So is it okay that I make walkthrough of code I already done, or is it more fun that I actually do live coding and cut that video into a coding video? Either way, I need to do these videos to rehearse my OpenGL skills myself, because I think I should use it to code a bit of small game later or something like that. So I needed to like have examples, and I rather have my own examples than I have example in the book and I need to dig through all the time. And why not share it on video? So that's kind of why I'm doing these videos. But you can comment down below if you think like the more live coding style or the walkthrough if both are okay, because the walkthrough is much easier to do. It's much less editing to do. Because other ways, like you code a bit and you make some serious error, you can go fine coding for 20 minutes, then you hit one error and you're stuck for an hour. So like it's not hard to cut out an hour, but it's hard to find that one when you're editing. It's like I need to remove this, and you have to look through it and it's like, oh no, did I do an error there? Or am I thinking about how to resolve that error? It's like, yeah, I am. I'm backing back, so I need to set the mark there. It's like, where in hell did I get back to coding correctly again? So walkthrough is easier in that sense. So yeah, this program is of course in the description, and I of course add in this program in the description also. So if you want to create a piano with sound, or if you don't care about sound, then you have the piano example without sound. That's a little bit easier to follow. And if you don't care about music and piano at all, which I totally understand, I can't play piano. I really wish I could, and someday I will learn. But that someday hasn't come yet. So, but if you want to test out Minecraft world that's not optimized, and you probably can't build a Minecraft world without bogging down your computer, then download that example instead. So happy coding. See you.